Okay, guys. Today's lesson is over 45, 45, 90 triangles, and that pertains to special right triangles. So you have your 45, 45, 90, which we're going to tackle today, and then 30, 60, 90 degrees, which we're going to tackle next time. In order to make this happen, we need to start with a radical review. So we're going to run through this. We're going to take our time because it's extremely important before we move to these special right triangles. And then once we've done that, we'll focus on the 45, 45, 90. You do have a skills check at the end of the period. The sub will hand it to you the last 10, 15 minutes. But we'll get through these notes. You'll have time to practice, and then you will have a skills check at the end of the day. All right. So for our warm-up, we are going to talk about radicals. So, number one, a blank is a number made by squaring a whole number. Does anyone know what that term should be? Okay, hopefully in your head, or somebody might have said it out loud, said perfect square. So a perfect square is a number that is multiplied by itself. Okay, so by squaring a whole number. Okay, so number 2 says list perfect squares up to 50. Okay, so let's start thinking of them. What is 1 squared? 1. 2 squared? 4. 3 squared? 9. 4 squared? 16. 5 squared? 25. 6 squared? 36. 7 squared, 49, and then you can go on, but we're just going to list them up to 50 for now. Okay, so it's important that you actually square the number. It's a number times itself and not just a number times 2. Okay, so 3 times 2 would give you 6, but we want to square it so that we get 9. Okay, so that is what our perfect squares are up to 50. Okay, when we are adding and subtracting radicals, in order to add or subtract them, the terms have to have the same radicand. Okay, or it's the number that's underneath the radical when simplified. Okay, so for example, the square root of 3, 3 would be my radicand. Okay, so we are going to practice adding and subtracting radicals in numbers 1, 2, and 3. Okay, make sure that you always simplify first if you can. Okay, so radical 5, we know that we can't simplify that. Minus 4 times the square root of radical 5, again, those are simplified. Okay, we cannot break down radical 5 anymore. Okay, so you have essentially 1 radical 5, because there's always an imaginary 1 out in front. 1 radical 5 minus 4 radical 5, which equals a negative 3 radical 5. Okay, we want to again make sure that the numbers underneath the radical are the same. That's the only way we can add and subtract, which they are. So all you do is you add the numbers that are outside of the radical, and then what's underneath the radical stays the same. So 2 plus 4 is going to give me 6. What's underneath the radical stays in prison. Okay, it's not being interacted with, it stays the same, and it's 6 radical 3. Okay, number 3, we're going to ask ourselves, can we simplify this first? Because that's always our first step. What is the square root of 9? Hopefully you said 3. What is the square root of 25? 5. So when you simplify radical 9 plus radical 25, it's really just 8. Okay, so that's adding and subtracting. So we want to make sure that the radicand, or the number underneath the radical, is the same before you add and subtract. Okay, and then once you do add and subtract, you don't subtract the numbers that are underneath the radical. It should stay consistent all the way through. Okay, it does not, you do not add them or subtract them. Consider them in prison, they're going to stay there. Okay, multiplying and dividing radicals. When multiplying or dividing radicals, you multiply or divide the numbers under the radical, and then multiply or divide the numbers in front of the radical. Okay, so this time we actually multiply what's underneath them. Okay, whereas before we left them the same. Okay, so now we're multiplying or dividing underneath and out front. So we're going to multiply the numbers out front. 2 times 4, which is 8. And then radical 6 times radical 5. 6 times 5 is 30. So this should be 8 radical 30. Okay. Now we have a fraction. Okay, so we're going to divide the numbers out in front. 18 divided by 6. Hopefully you get 3. Radical 24 divided by radical 3. We're going to take the numbers inside, which is 24 and 3, divide them, and that should give you radical 8. Okay, adds in parentheses. Don't know what happened to them, but it's alright. Okay, so now we have to distribute across our parentheses. Okay, so we have a radical 2 times 3 radical 5 plus radical 2 times radical 2. Okay, so let's look at one at a time. Okay, so this is a multiplication problem. This is a multiplication problem. Okay, we can multiply the numbers out in front times each other. So 1 times 3, which is 3. Square root of 2 times the square root of 5, which is the square root of 10. Plus the square root of 2 times the square root of 2 is the square root of 4. Okay, can this be simplified anymore? Okay, I can't simplify radical 10 anymore, but what is the square root of 4? Very good, 2. So your final answer should be written like this, because this is the simplest form. If you were to give me this, okay, it's not necessarily wrong, it's just not simplified because radical 4 is 2. Okay, so make sure you double check your answer that it's all the way simplified. Okay, turn the page. Okay, now we are going to talk about actually simplifying the radicals. Okay, so simplifying that number underneath the radical as much as we can. Okay, so a square root radical is simplified, or it's in its simplest form. When the radical has, sorry, not when the radical, the radicand has no square factors. And what I mean by square factors is no perfect square, like the ones we wrote on the first page, that 1, 4, 9, 16. No perfect square could go evenly into the radicand. Okay, so once it is simplified, 1, 4, 9, 16, etc., none of those numbers can go evenly into it anymore. So, some steps to simplifying radicals. Find the largest perfect square that is a factor of the radicand. Rewrite the radical as a product of its factors and then simplify. Okay, so real quick before we move on, I want you to write a list of your perfect squares. So we started writing them on the front, but let's take some time and write it. Let's go up to 100 so that we have them all here. 1, 4, 9, 16, 25, 36, 49, 64, 81, and then you have 100. So this was 1 squared, 2 squared, 3 squared, 4 squared, and so on. Okay, So, for example, when simplifying square root of 8, okay, I want to take the number that's underneath my radical, so my radican, and that's 8, okay? And then I'm going to go look at my perfect squares. I'm going to look at putting this number in lineup. So, like, 8 would fit somewhere in here. Okay, so I know that 9 can't go into 8, 16 can't go into 8. None of that would make sense because all these numbers are bigger than 8. However, I can look at 4 and 1. Does 4 go in evenly to 8? Yeah, because 4 times 2 is 8. So when we break down this radical, its square root of 8 is equal to the square root of 4 times the square root of 2. Okay, so just like we practiced multiplying radicals on the other side, square root of 4 times the square root of 2, multiply what's underneath the radical, you get square root of 8. But now we can simplify once we've rewritten it like this, because the square root of 4 is 2. Okay, so now let's practice 1, 2, and 3. Okay, so the square root of 8 simplified to 2 radical 2. Let's see what these simplify to. Okay, so look at the number underneath the radical, so your radican, 72. Okay, 72 is going to fit somewhere in here. Okay, is 64 going to go into 72 evenly? No. Is 49 going to go into 72 evenly? No. What about 36? Is 36 going to go into 72 evenly? Okay, some of you might just be sitting there, which I'm sure there's a lot of you. Get your calculator and see, does 36 go into 72 evenly? Okay, very good. It goes in there how many times? 2. So, when you rewrite this as a product, you have the square root of 36 times the square root of 2. Okay, well, what is the square root of 36? 6, and then you tag on that radical 2. So square root of 72 simplifies to 6 radical 2. Okay, let's look at number 2. Okay, put 24 in your lineup. Okay, so we know that we're messing with these numbers. Okay, is 16 going into 24 evenly? No. Is 9 going to go into 24 evenly? No. How about 4? Can 4 go into 24 evenly? Yes. 4 times what? Radical 6. Very good. What is the square root of 4? 2. And then you have radical 6. So you know you are simplified when once you get the number underneath the radical, okay, and then it no longer can have a perfect square going into it evenly other than 1. Okay, so like 4 can't go into 2. 4 can't go into 6. So we know we're simplified. Okay, let's go and on to number 3. Square root of 56. Okay, so we're going to put 56 into the lineup. Okay, it's going to go somewhere in here. Okay, is 49 going to go into 56 evenly? No. Is 36 going to go into 56 evenly? No. 25? No. What about 16? No. Okay, keep on going. Is 9 going to go into 56 evenly? No. Is 4 going to go into 56 evenly? Type it in on your calculator. 56 divided by 4. Does it go in evenly? Very good. How many times? 14 times. Okay, so square root of 4 is what? 2, and then you have radical 14. So square root of 14, okay, is one of our larger numbers, okay, that is actually simplified, because if you put it into your lineup, it would be right in here. Is 9 going to go into 14 evenly? No. Is 4 going to go into 14 evenly? No. Okay, so it is simplified. Okay, so that is simplifying radicals, and you will have some of these on your skills check, so make sure you know how to use the perfect squares in order to get them simplified, and you'll have your calculator as well. Okay, let's look at 4 through 7. Okay, so you're solving for the variable. Leave answers in simplest radical form. Okay, so what are we going to do in order to solve for x if I tell you guys all these are right triangles? What are you going to have to do? Very good. Hopefully you said Pythagorean theorem. Okay, and remember Pythagorean theorem, a squared plus b squared equals c squared. Okay, let's look at number 4. Okay, are we solving for a leg or a hypotenuse? Hypotenuse. So, for number 4, I have a squared plus b squared equals c squared. 1 squared plus 1 squared equals c squared. 1 plus 1, which is 2. In order to get c by itself, I take the square root. It's the square root of 2 in simplest form. Yes, it is. Very good. Okay, let's look at 5. Okay, am I solving for the leg or the hypotenuse? Hypotenuse again. So I have 2 squared plus 2 squared equals c squared. So 4 plus 4 equals c squared, which is 8. Square root of both. Okay, now I have 8. So put 8 into your lineup. Okay, it's going to go in here. Can 4 go evenly into 8? Yes. Okay, so that's the square root of 4 times the square root of 2. What is the square root of 4? 2. So 2 radical 2 equals c. That hypotenuse. Okay, number 6. A squared plus b squared equals c squared. What are we solving for this time? Okay, a leg. So we have 1 squared plus b squared equals radical 2 squared. 1 plus b squared equals, what happens when you have a radical 2 squared? Okay, hopefully we are able to recognize that when you square a radical, that the square and the radical undo itself, and you're left with just the radical, or just the number underneath the radical, which is 2. And the reason being, if I have the square root of 2 squared, that is saying square root of 2 times the square root of 2. The square root of 2 times the square root of 2 would give you the square root of 4, and then the square root of 4 is what? 2. So, rather than working all that out, a shortcut is just to cancel out the square root and the radical, and then take just what's left underneath the radical as the answer. Okay, so I'm going to subtract 1 from both sides. I have b squared equals a positive 1. Take the square root of both sides. What's the square root of 1? 1. Very good. Okay, and number 7, it's going to run out of room probably. Leg or hypotenuse? Leg. So we have a squared plus 2 squared equals 2 radical 2 squared. Okay, so you have a squared plus 4 equals. Okay, this time when you have something like this being squared, a number and the radical, you have to make sure you square both terms inside. So you have to square the number out front, and you have to square the number underneath the radical. So I need to make sure that I square both of these values. So 2 squared is what? 4. Square root of 2 squared, just like over here, the square root of 2 squared is 2. So you take the product. So I have a squared plus 4 equals 8. And if you ever get hesitant on stuff like this, type it into your calculator. Just make sure that you have parentheses around this before you have your square. Okay, so a squared plus 4 equals 8. Subtract 4 from both sides. A squared equals 4 radical. A equals what? 2. Very good. Okay, we are almost done. Okay, the next part is extremely important for what we are about to do with our special right triangles. Okay, and that is rationalizing the denominator. Okay, a number is never simplified if there is a radical in the denominator. Okay, so in order to rationalize the denominator with a radical, multiply the fraction by a radical that will get rid of the radical in the denominator. Okay, so that's a bunch of fancy wording for basically multiplying the radical times itself. That way, those square roots can undo themselves and you're left with just the radical underneath. Okay, so let's put it into practice. So, if you had an answer that looked like this, 2 over the radical 3, okay, you're going to multiply the numerator and the denominator by radical 3. So whatever you do to the top or bottom, you have to do to the other, okay? So, in order to get rid of this radical 3, I need to multiply by radical 3. So I'm going to multiply top and bottom. Equals, okay, then you multiply numerator times numerator, denominator times denominator. Okay, so 2 times the square root of 3 is 2 square root of 3. A square root of 3 times itself equals 3. Okay, because that's squaring. I could rewrite this if I wanted by radical 3 squared. And just like I told you on the other side, those undo themselves and you're left with just the number underneath the radical, which is 3. Okay, so that is how we are going to rationalize the denominator. Okay, so let's put this into practice. For number 1, okay, notice how the radical is over the entire fraction. Okay, so before we simplify, okay, and rationalize the denominator, let's make sure that our fraction doesn't simplify first. So, does 28 over 7 simplify? 28 over 7 is equivalent to 4, and we know that the square root of 4 is what? 2. Very good. Okay, number 2 is 2 over radical 2. How am I going to get rid of radical 2 in the denominator? What do I need to multiply top and bottom by in order to get rid of radical 2? Okay, hopefully you said radical 2, because basically whatever's in the denominator, you're multiplying it by itself, top and bottom. Okay, so now 2 times radical 2 is 2 radical 2. Okay, then I have radical 2 times radical 2. Okay, what happens when I multiply radical 2 times radical 2? Very good, it's just 2. Okay, because the square roots undo themselves. Okay, now I have 2 radical 2 over 2. What is this simplified to? Very good, those cancel, so this should just be radical 2. Okay, number 3, again, you just want to make sure that before you create more work for yourself, you see if you can simplify anything on your own first. So, you have 4 over radical 4. Well, does any of this look familiar, something that you can simplify? Very good. Radical 4 is equivalent to what? 2. So 4 over 2 is what? 2. Okay. Can 3 over 4 simplify? No, it's already in simplest form. So now, unlike in number 1 where we got radical 4 and we are done, okay, now we need to break apart our radicals. So we have radical 3 over radical 4. Okay, that's all that big radical means, that you're taking the radical of both, top and bottom, numerator and denominator. Can the radical 3 be simplified any further? Are there any perfect squares that go evenly into 3 other than 1? No. So we know that's simplified. What about radical 4? What does radical 4 equal? 2. And as long as we don't have any radicals in the denominator, we are simplified. Okay, let's look at number 5. Okay, 5, we have 4 over radical 6. Okay, how am I going to get rid of radical 6? Multiply top and bottom by radical 6. Okay, when I multiply 4 times a radical 6, I get 4 radical 6. When I multiply radical 6 times radical 6, my square roots undo each other. So I'm just left with the number underneath the radical, which is 6. Make sure you don't make the mistake of multiplying those numbers together. Okay. Okay, then I have 4 radical 6 over 6. Can this simplify any further? Very good. What can be simplified? To 2/3. So my answer is actually 2 radical 6 over 3. Okay, it's extremely important that when you are simplifying, okay, the numbers underneath the radical are in prison. Okay, they can't interact with the numbers on the outside. Okay, so when I simplify this, it doesn't become 2 radical 3 over 3. Okay, I only can simplify 4 and 6 because those numbers are outside of the radical. Okay, so I cannot simplify numbers that are in prison, okay, unless there's another radical. So make sure you don't make that mistake. Okay, number 6. Okay, how am I going to get radical 2 out of the denominator? Very good. Multiply top and bottom by radical 2. So now I have 5 radical 3 times radical 2 over radical 2 times radical 2. I rewrote it just so that we can see what we're working with. Okay, so I can multiply the two numbers outside, so just imagine there's that 1 there. So 5 times 1, which is 5. Radical 3 times radical 2, radical 6. Radical 2 times radical 2, which means those undo, and you're left with just 2. Okay, and can 5 halves simplify anymore? No. So we are done. 5 radical 6 over 2. Okay, so you will have some like this on your skills check. Okay, so you're going to have to know how to rationalize the denominator. Okay, so make sure that you always check if you can simplify first. Like if you can simplify your fraction, or if you can simplify a radical that they've already given you. Okay, so make sure you check for those things first. Alright, so this was our radical review, and this is what's going to help us with the next lesson, which is 45, 45, 90 right triangles. So get the next section of notes out. Okay, should look like that. Okay, these are just one sheet of notes. It shouldn't take long. We've done the hard part, so y'all made it through the hard part. Now we're just going to apply it. Okay, so 45, 45, 90-degree right triangle. So, given the following square, okay, it says draw in the diagonal. So let's do that. If you don't have a straight edge, it doesn't have to be perfect. Just draw a diagonal. Okay. Use the Pythagorean theorem to find the length of the diagonal. Okay, so a squared plus b squared equals c squared. Are we solving for the leg or the hypotenuse? Okay, hopefully you said hopefully you said hypotenuse. So I have 1 plus 1 equals c squared. Radical of both sides, square root of 2 equals c. Do we agree? Is radical 2 simplified? Yes. Okay, so for number 3, it says, what are the angle measures for the two new triangles? So if I know this is a square, all 4 angles have to be what? 90 degrees. So if now I'm cutting a diagonal, okay, so I'm bisecting my shape essentially diagonally, what are these two angles now? Very good. 45 degrees apiece because you just divided 90 by 2. Okay, so I have a 45, 45, 90 degrees. Okay, what do we call triangles that have two legs that are equal, or two equal sides? Okay, an equilateral has 3 equal sides, so what do we call something that only has 2 equal sides? Very good, an isosceles. So the diagonal of the square creates 2 isosceles, 45, 45, 90 triangles. Okay, I want us to label the legs and the hypotenuse of this triangle. So what is over here? This side is a leg. This side is a leg. And this side is what? Very good. Hypotenuse. What do we know about our hypotenuse? Across from the right angle. Very good. Longest side. And it is the C value in Pythagorean theorem. Okay, so keep all that stuff in mind. Okay, so now we are going to find a trick to do, instead of having to do Pythagorean theorem all the time, there are rules in place for 45, 45, 90 triangles. Okay, so these are also on your formula sheet. So if you have it, great. If not, I'm going to show you up here. So you'll never have to memorize this because it's going to be on your formula sheet. Okay, so we're focused right here. Okay, your legs represent what variable? X. So your legs are X. Your hypotenuse represents what? X radical 2. Okay, so these are the lengths of your 3 sides. Always. Always, always. And then you're responsible for just solving for X. Okay, so to solve for a leg, you would take your hypotenuse and divide it by the square root of 2. Because right now I know my hypotenuse is X radical 2, and I want just X. So in order to get X by itself, I would have to divide the hypotenuse by radical 2. Okay, so to solve for the hypotenuse, I'm going to multiply my leg times radical 2. So I'm going to take my X value and multiply it by radical 2. Okay, so those are your shortcuts for solving for a leg and solving for a hypotenuse. Okay, or if you know X, X, X radical 2, same thing. Okay, so for number 1, am I solving for a leg or a hypotenuse? You're solving for a leg. So you need to take your hypotenuse over square root of 2. Well, what is my hypotenuse? 4 radical 2 over radical 2. What happens here? Very good. The radical 2's cancel out, and you're left with your leg just as 4. If this leg's 4, what's this leg? 4. So remember, it's X, X, so your legs are always congruent. X, X, X radical 2. So 4, 4, 4 radical 2. Okay, and notice that sometimes your pictures aren't always drawn to scale. This side does appear longer, but it is 4, 4, 4 radical 2. Okay, number 2. Okay, if I'm looking at Z, okay, and I already have one leg, what do I know Z has to be? Very good. The legs have to be congruent. So if this is 8 radical 2, this has to be 8 radical 2 as well. Okay, now looking at Y, okay, I have 8 radical 2 times radical 2 because I'm solving for the hypotenuse. And remember, to solve for the hypotenuse, you're taking your leg length, multiplying it by radical 2. So 8 radical 2 times radical 2. Well, that's 8 radical 4. But what is the square root of 4? 2. So what is the length of my hypotenuse? 16. Okay, remember that you can only multiply the numbers outside times each other and the numbers underneath the radical times each other. You don't multiply 8 times 2 times 2. Okay, it's only the numbers underneath the radical, only the numbers outside. Okay, turn the page. Okay, number 3. Okay, are we solving for legs or hypotenuse? Okay, we're solving for our legs. We're given the hypotenuse, which is 7. Okay, so we know when we're solving for a leg, you have to take the hypotenuse, divide it by radical 2. Okay, so if I substitute in, I have 7 divided by radical 2. Okay, is this simplified? No. Why? Because you cannot have a radical underneath the denominator. So how am I going to get rid of radical 2? What do I need to do? I need to rationalize my denominator. What do I need to do to get rid of radical 2? Very good. Multiply top and bottom by radical 2. So I get 7 radical 2 over, and what happens when you multiply radical 2 times radical 2? Very good, you just get 2. So what are the lengths of x and y? 7 radical 2 over 2. Very good. Okay, for number 14, okay, again, I have the hypotenuse and I need my legs. Okay, so I know I'm going to have to do hypotenuse over radical 2, which is 14 over radical 2. This time I want you guys to take a second, I'm not going to do it, and I want you to make sure that that is simplified. Okay, so take a second and simplify that leg length. Okay, hopefully you multiplied top and bottom by radical 2. So I have 14 radical 2 over 2. And then once you get here, see if the numbers outside the radical can simplify. And 14 over 2 does simplify to 7. So it should be 7 radical 2. Okay. So that's really it for the 45, 45, 90. We're going to go through these little practice problems real quick. But apart from that, the hardest thing is just getting the denominator rationalized. Okay, so if you feel comfortable doing this stuff, awesome. Okay, so again, some of that will be on your skills check as well. So you have anything with radicals and then 45, 45, 90. Okay, so number 1, okay, remember, and maybe start getting into the habit of labeling what each of the sides are. So maybe in a different color, you would say, okay, my legs are x, and my hypotenuse is x radical 2. So what information do I have right now? I know that x equals 6. Okay, so now I need to substitute in 6 for x. So my hypotenuse is 6 radical 2. Okay, I have x radical 2. Okay, well, I know that 10 equals x radical 2. because that's the measure of that side. So in order to get x by itself, I have to divide both sides by radical 2, and I get 10 over radical 2 equals x. And then I have to rationalize it. Okay, so I have 10 radical 2 over 2, and then 10 over 2 simplifies to what? 5. Very good. Okay, so if you memorize the steps on the front, okay, these little tricks, that's fine. If you don't memorize it, just know that you could solve it like this, okay, because it's essentially the same thing. You're just skipping the step of setting up the algebra equation, okay. So you know that the hypotenuse is equal to x radical 2. So I could set 10 equal to x radical 2 and then divide, which essentially is the hypotenuse divided by radical 2. Okay, so either way you should be in good shape. Okay, number 3. Okay, if this is 5, A equals 5, and B would equal 5 what? Radical 2. Because again, 5 is going to equal x. So 5 equals x, then x equals 5 still, and then 5 radical 2. You're just substituting in for x. Okay, number 4 is what I was kind of talking to you guys about earlier, just that triangles aren't always drawn to scale, so make sure you pay attention to those angle degrees. Okay, so if this leg is 15 degrees, this leg has to be, very good, 15 degrees, which makes G what? 15 radical 2. I don't know why I said degrees, just 15. Okay, who knows what happened to 5, but skip to 6. The diagonal of a square is 18 inches. Find the perimeter. Okay, so if we know the diagonal is 18, what are we going to have to do in order to find the perimeter? Very good. You're going to have to find a leg length, and then you multiply it by 4 because it's a square. Okay, so we know 18 is on my hypotenuse, so I have x radical 2, so I need to go solve for x. So if 18 equals x radical 2, in order to get x by itself, I need to divide both sides by radical 2. Okay, so I have 18 over radical 2 equals x. You need to simplify this now. Sorry, rationalize the denominator. So I have 18 over radical 2 over 2. 18 over 2 simplifies to just 9 radical 2 equals x. So I know this side 9 radical 2, I know this side, and because it's a square, all my sides are 9 radical 2. So if I need to multiply 4 times 9 radical 2, okay, remember you can't multiply a number not underneath the radical with a number underneath the radical. You can only multiply the numbers out in front. So 4 times 9, 36 radical 2 inches. Okay, so these are more how your test questions are going to be. They're going to be more application based. So not just solving for the leg or the hypotenuse. They're going to be like, okay, solve for the leg, the hypotenuse, and then give me something else, like area, perimeter, what have you. Okay, so over here we have x radical 2. We need to solve for our what? Our legs. Okay, so we know that 8 equals x radical 2. So divide 8 radical 2 is equal to x. I need to rationalize my denominator. So I get x equals 8 radical 2 over 2. And 8 over 2 simplifies to what? Very good. 4 radical 2 feet. And that's going to be the length of what? X and Y, because they are the legs and the legs are congruent. Awesome. Okay, so you guys have about 40 minutes left of class. That skills check is going to be the last 15, probably 20 minutes, just to give you guys extra time just in case. So that leaves you guys with 20 minutes, probably, give or take, to work on the assignment. So the sub's going to come around with the assignment. Work through that, the answers to the notes, the assignments, everything will be up here with the sub or on the board wherever he or she puts it. And that way you can check your answers as you go. But make sure you know how to rationalize your denominator, simplify those radicals, okay? And like I said, it's going to be important for next lesson too, when we get to 30 degrees, 60 degrees, and 90 degrees, okay? Like I said, the x radical 2 is on the formula sheet, so should you not memorize it, you will be able to have access to those for the skills check and any future tests, quizzes, whatever. But if you guys have any questions, don't hesitate to email me or come in for a tutorial. So I will be here tomorrow, okay, during Mega Lunch. I lied, I won't be in Mega Lunch because I have duty. But before school or after school, I will be available if you need any help. Okay, guys, good luck. Make sure you use your class time wisely.